Mrs. Casto back with you. Number 6, our last one for our Chapter 1 Quick Quiz Test Corrections. Now this one's kind of like the one we were doing over here because unit rate is a surefire way when they're saying which drink is the better buy. And some of you were questioning that. That's the same thing as better deal. Which one's cheaper? You know, where are you going to get more for your dollar? So that is one way to do that. Some people got how many ounces per dollar. That is one way to do it. But usually I put money on top. So I'm going to find the unit rate for the first one. So I'm going to first get my answer set up. The blank ounce drink is the better buy because blah, blah, blah. We don't know yet, okay? This is going to be my justification, justifying my answer. And it might be a big sentence or it might just be a comparison that you write down with less than or greater than. There are lots of ways to explain it, but I'm just going to model one or two. So we've got the one that's $2.16 for 6 ounces. Okay. Now I've done no math. All I've done is looked at the 6 ounce drink, $2.16. My job to get it to 1 ounce. Okay. Then I'm also going to compare that to the other one that is $3.25. Oops. $3.25 for 10 ounces. My job is going to be to get it to 1 ounce. Again, there are other ways of doing that. And I just want to show you everything in purple. I did no math. All I did was, thanks. All I did was set up what they gave me. So now I'm going to do some math. And I can divide the numerator by the denominator. 216 divided by 6, it's going to give me 0.36 on the nose. Okay, so 36 cents for every ounce of that drink. So 2 ounces would be another 36 cents. Do you see how that works? So this is for 1 ounce. I found the unit rate. I'm going to compare it to this unit rate. I don't even need a calculator for this one, guys, because divide by 10 we love. We love divide by 10, multiply by 10, add 10, subtract 10. It's our best friend because all I have to do is move the decimal point over 1 place because there's 1 0. So the unit rate is 325 thousandths of a dollar per ounce. But that looks weird. That's weird, right? We don't do money like that. So we have to decide. I only need 2 places past the decimal point. It's either going to be 32 cents or 33 cents. Well, next door is a big guy, 5, 6, 7, 8, 9. That has the power to change that 2 to a 3. If this were a 4, 3, 2, 1, or 0, weak, so the 2 stays. But since the 5 has the power, this rounds to 33 cents. Now that looks like money. You know money, okay? Whenever you get stressed out on a math test, just like take a deep breath and be like, okay, what makes sense? I'm going to think logically about this. So now I'm going to the store or whatever it is, and I'm deciding. I want to get the most for my money. Do I want this one, 36 cents per ounce, or this one, 33 cents per ounce? Okay, we know, just like in first grade, 33 hundredths is less than 36 hundredths. So this is the best deal, the 10-ounce drink, because 0.325 is less than 0.36. That's one way to justify it. Even though it has more digits, this is 325 thousandths. This is 36 hundredths. What else, Miss Hellman?
All right. Some of you chose to answer the problem a slightly different method. Using what we know about equivalent ratios, you turn them all to have 30 ounces. So to have the same denominator being 30. So to do that, you multiplied for the bottom. So for the 10-ounce container for $3.25, you would have multiplied by 3. So you're doing the same thing on the top that you did to the bottom. And using my calculator here, I have $3.25 time, oops, that's not a 25 cents times 3. Nope. What are we multiplying by? Oh, we are multiplying by 3. Multiplying by 3 gives me $9.75.
I would love to know who thought of that. It's just a really great math idea.
And then we're going to compare that with, for the next one, to go from $2.16 for 6 ounces to some price for 30 ounces, you had to multiply 6 by 5. So whatever you did to the bottom, again, you're going to do to the top if you're treating these like equivalent ratios, which you could. So we're going to take 2.16, so $2.16. Whoops. There we go, $2.16. We're going to multiply it by, oh, can you see? Multiply it by 5, and we get $10.80. Notice that there's no zero there, but we know we're talking about money, and money goes to the hundreds place, so we have to put in our placeholder. All right, now looking at the 2. If we buy 30 ounces of each one, we still want the option that gives us where we have to pay the least amount. And that again would be the 10-ounce container. So you can compare it that way. We're looking for which one again do you get? Do you spend the least amount of money for the same amount?
Let's just prove this real quickly to see why. Take this 1080 and divide it by 30.
Will do. Dividing our 1080. So I'm going to take $10.80. Make sure you can see $10. Oh, I should have used my good button, the answer key button there. $10.80 divided by 30 brings me to 36 cents.
Oh, that sounds familiar.
Yep.
Yes, no matter what, when you have equivalent ratios, you're going to get the same unit rate. You can guess, you can try it on your own, guys. 975 divided by 30, I bet you're going to get this answer here. Unit rate, numerator divided by denominator.
Good stuff.
Woohoo, done.